So, we are going to think about chemical bonding. All chemical bonding is strong electrostatic force of attraction between something that has a positive charge and something that has a negative charge. That is different from intermolecular forces. Those are a weak force of attraction, and that is always between molecules. Oh, I haven't spelled that very well. And you can get that link. So intermolecular forces are between molecules. And those are different from chemical bonds. All right. So now we're just going to talk mostly about chemical bonds. There are three main types of chemical bond. These are, stop and think if you can think about what these are. Metallic, ionic, and covalent. Different types of element form different types of bonds. So metallic bonding is when we just have metals present. Ionic bonding happens in compounds made of metals and non-metals. Those form ions, and that's a helpful way to think about what ionic bonding is. Covalent bonding is in elements or compounds that only contain, think what I'm going to write here, non-metals. All right, so I want you to pause the video now and try to remember, write down this skeleton So write down copy down this and try and fill in the gaps. So just pause the video and do that. Okay, check your answers, pause and check. Okay, moving on now. How does metallic bonding happen? So, metal atoms, remember how metal atoms form ions? They have a small number of electrons in their outer shell, so they lose electrons which become delocalized and form positive ions. So what this looks like is positive metal ions. Those have formed from metal atoms losing an electron. Those electrons are delocalized the atoms and in between the positive metal ions. How does that compare to how ionic bonds form? So, in this case, metal atoms lose electrons and non-metal atoms gain electrons to form positive and negative ions. What that looks like then is a lattice that forms between positive and negative ions. So these are positive ions from the metal. Let's just call them positive metal ions. Positive metal ions. These are negative non-metal ions. Okay, so covalent is only made, covalent bonding is from only non-metals. Non-metals don't want to lose electrons, they want to gain them. So, because they can't gain them, because there's nothing to lose them, non-metal atoms share electrons. And I'm going to show you a couple of ways in what that might look like. Yeah, that's not great. So they might form a big network of atoms. More commonly, covalent bonds form in groups of atoms. So in both cases, oops, that's the wrong way. These are covalent bonds. This is in a giant lattice, and the examples that you know about that are diamond, graphite, graphene, whereas these, which are the vast majority of covalent compounds, are molecules. Now we have to zoom in a little bit to understand what the covalent bond is. We actually have to do a bit of a dot and cross diagram. So for instance, in water, we show shared pairs of electrons in the bond between oxygen and hydrogen. So this here is the covalent bond. So let's just think back. Actually, let's pause there. And you're going to try and build out your diagram that you did last time a little bit more. So I'm going to erase what goes on here. So I'll just let you label those. All right, so now build out your diagram that you've started in your book and see if you can, as you do so, you can fill in the missing words. Pause the video. Okay. Check your work. Pause the video, check your work. Oops. All right. So now let's think back to what we were talking about before. What did we say a chemical bond was? Think if you can remember what we said a chemical bond was. We said it is a strong electrostatic force of attraction between a positive charge and a negative charge. So let's see if we can think about what these are in each of these. So metallic bonding, the positive charge is the positively charged metal ions. And think what the negative charge is. That is the delocalized electrons. So, the metallic bond is the strong electrostatic force of attraction between think what I'm going to write now. Positive metal ions and negative delocalized electrons. So remember what we said a chemical bond was? It was a strong electrostatic force of attraction between something positive and negative. Metallic bonds are a kind of chemical bond, and they have a strong electrostatic force of attraction between positive metal ions and negative delocalized electrons. Right. Before I do it, see if you can think about how we're going to write the same sentence for ionic compounds. Pause. Okay, so I'm going to mark up my diagram. As before, the positives here, oh, there's a mistake there, it should be a negative, are the ions that form by metal atoms losing electrons and becoming positively charged, and the negatives are the negatively charged nonmetal ions. So under your diagram now, see if you can write a definition of the ionic bond. Pause and do that. Okay, check your answer. So we've got positive metal ions and negative non-metal ions. Notice the same words start the definition every time we write a definition of a bonding. Strong electrostatic force of attraction between. Then we say what the positive is, then we say what the negative is. All right. So, covalent bonding is a little bit more tricky to see here. The covalent bond I've indicated, but it is not obvious from this diagram what is the positive and what is the negative. One thing we know for sure is that electrons are negatively charged. What is positively charged here? It is the protons in the nuclei. So I'll just do one big plus for oxygen rather than try and show all the protons, but you should be able to work out that there are 8 protons in the oxygen nucleus. So, in this case, if you think that you can write this one yourself, then pause, otherwise follow through with me. So, it's really important that we say a couple of things here. We have to say that it is a nuclei of 2 atoms that the attraction is between. because obviously there is always an attraction, for instance, in a hydrogen atom, between the positive nucleus and the electron. There is going to be an attraction there, that's why the electron stays, but that is not a covalent bond. So we have to say in our definition that this covalent bond comes from, let's do it for another hydrogen atom here. If we're making a hydrogen-hydrogen bond, then it's both nuclei that are attracted to those electrons, and that is why it is a covalent bond. And we also need to say it is a shared pair of electrons. That word pair is very important. That shows that we know that each covalent bond is 2 electrons. All right, I'm going to ask you, guess what, to pause the video and practice those definitions. So that's metal, so that's ionic, and that is covalent. So under your diagrams, a definition of each kind of bond. Pause the video and do that. Okay, check your work. Right, the last thing I just want to talk about now is what we mean by structure. So structure is how the particles are organised in different substances. In metallic substances, they are always organised in layers that go on and on and on and on. The on and on and on bit, we call it a giant because it goes on and on and there isn't a start and a finish. We call it metallic to show that it's only a metal in there. And to show that it's a regular arrangement, we call it a lattice. So the structure of an ionic substance is a giant metallic lattice. Think if you know what the structure of an ionic substance is. Again, there isn't a start or a finish to this network of ions. I could keep drawing them, I could draw more, I could draw fewer. So because it doesn't have a start or a finish, it's called giant. To show that it's made of ions, we call it ionic. And again, to show that it's a regular arrangement, we call it a lattice. So, in covalent substances, we can have 2 kinds of structure. And I've already talked about what these was. So when there's lots and lots and lots of atoms that are covalently bonded to each other, and it could go on and on and on and on, we call it actually, probably more, we're going to call it a giant covalent structure. More commonly, and this is the only structures that you need to know about for giant covalent are diamond, graphite, and graphene. And we'll do a little bit. There's separate work on that. That's not the main point for the moment. The structure for nearly every covalently bonded substance is simple molecular. And that is for any substance, really, for our purposes, that has a formula that shows a number of atoms. So for instance, water carbon dioxide, oxygen, methane, chlorine. You can see all of these are compounds, or elements indeed, two of them elements, that they've all only got non-metal atoms in them. That means their bonding must be covalent. The fact that they have a formula, and indeed that they're not diamond, graphite or graphene, so the formula for all of these is just C, means that they have a simple molecular structure. All right, I think you can now go on to do the worksheet.